Hi, my name is Amira.
My name is Afza.
So actually we are both working in this project entitled
Platinum-free, low-cost and efficient counter electrode for PANI-GO Nanocomposite for the DSSC. So, for the introduction, what is DSSC? So DSSC is a solid-state photovoltaic or photoelectrochemical cell imitating the concept of plant photosynthesis process. Looks like. So this is the structure of DSSC. It is made up of glass consisting of ITO followed by the photoanode, which consists of TiO2, and then dye followed by the electrolyte, and then for counter electrode, which is platinum, and last but not least the ITO glass.
So, do you guys know how it works?
A photon enters the solar cell through anode, which is made up of wide bandgap semiconductor, which is TiO2. The dye molecule absorbs photons of wavelength corresponding to energy difference. The electrons from the ground electronic state of dye are transferred to excited state by the phenomenon known as photoexcitation of dye. This electron in the excited state of dye is injected to conduction band of TiO2. The electron from the conduction band of TiO2 are transported through the semiconductor by diffusion process and reaches conducting layer of ITO, also known as current collector. The electron can perform work and flow to the cathode through the external circuit where they can produce electrical power. Then, they re-enter through the cathode where they drive a reduction oxidation process in the electrolyte solution. Platinum is being used in commercial DSSC as cathode material. We are modifying the cathode by using PANI-GO. The triiodide electrolyte gives the electron to the oxidized dye at anode and regenerates the dye molecule in order to allow the process to continue. The current flows through the circuit as long as the light falls on the cell.
Is there any limitation in the fabrication of DSSC? So we have an answer after this. On 19th century, mesophorous titanium dioxide or TiO2 is actually the third of photovoltaic technology founded by Michael Gratzel, and it's found that the good conversion efficiency can up from 6 to 7%. And on 2006, Portsman et al. Actually reported that the durability of this DSSC is around 20 years. Wow, it's quite a long period. Recently, the DSSC is suffering from drawbacks such as low efficiency compared to that of the current photovoltaic technologies. The cells in DSSC only can be integrated into low power gadget, so this is actually lead to our first limitation. Have you remembered that counter electrode that I've been using in a commercial DSSC is platinum, but in our project we won't use platinum, so that's why our title is platinum free. So why we don't use platinum? Because the main reason due to its expensive. So actually, conducting polymers are frequently used electrode materials for pseudocapacitor because of their low cost, high conductivity, and facile synthesis. Conducting polymer, especially polyaniline, show an extremely high theoretical capacitance up to 2000 farad per gram. And the electrochemical available active surface of PANI greatly depends on the conductivity of PANI and the diffusion of counter ion, and thus only a small amounts of PANI could make contribution to the capacitance. So it's actually lead to our second limitation, in which the experimental value of PANI electrodes are much lower than the theoretical value. So that's why PANI will undergo severe volume changes during cycles, and the cycling stability is also a problem to be solved. So here come an idea that we want to mix PANI and graphene oxide. So graphene is actually exhibit high conductivity, large surface area, flexibility, and excellent chemical stability. However, easy aggregation of graphene lead to the decreased surface area and capacitance lower than 200 farad per gram as electrode materials. So that's why, based on previous research by T. Wang 2017, PANI reduced graphene oxide nanocomposites have emerged as an ideal choice as promising electrode materials. But this idea is actually new, which is lead to the new limitation can be discovered. So that's why we've come up with an idea, which is PANI and graphene oxide can be chosen as counter electrode replacing the platinum.
Fabrication of DSSC. How to fabricate dye-synthesized solar cell or DSSC. The materials that you need is dye itself, electrolyte, and a counter-electrode PANI-GO, and for a photoanode, titanium dioxide, and last but not least is ITO glass. First, please prepare the photoanode and counter-electrode by applying the PANI-GO and TiO2 on the glass and let it on the hot plate for a few minutes for drying. And after that, immerse the TiO2 glass in a dye for 15 minutes and wash it with distilled water, and after that, apply electrolyte. So these two electrode is combined together with a paper clip on both sides and is ready to be used as DSSC. Application of DSSC. The application of DSSC actually can be integrated into low voltage devices. Make sure the photoanode is facing towards the solar source and the voltage reading will slowly increasing. And after a few moments, it goes up to 0.6 volt. In order to light up one LED, which is required around 1.5 volt, we need another 3 DSSC. It's guaranteed that our project is successfully working. We believe through a further research, our platinum-free modified DSSC, which is less expensive and easy to fabricate, can be widely used in a low and high voltage devices.